Good morning children, welcome to YouTube learning. So in our previous videos we have started learning about the lesson energy, right? In that we have discussed about the concept of work done, definition, standard units, mathematical expression and also some numerical examples. In my previous video I had started about the concept of energy. In that we have learned about two forms of mechanical energy. One is potential energy and the other is kinetic energy. So we had taken up the study of potential energy. In my previous class I had told you about the definition of potential energy and also the mathematical expression of potential energy. So potential energy basically is the energy possessed by a body by virtue of its position or configuration. So whenever a body is at rest, energy will be stored in the body as potential energy. Now if you take a body like a rubber band or a spring and stretch it, then the body will be in stretched condition. Then also the energy will be stored in the body as a potential energy. Now potential energy, basically there are two types again, gravitational potential energy and elastic potential energy. Gravitational potential energy means what? As the height of the body increases from the ground level. So the height of the body increases from the ground level, then what happens? The gravitational potential energy will go on increasing. If the body is on the surface of the earth, on the ground, then its gravitational potential energy will be zero. Okay, and as I have told you, if you take a spring and stretch it or compress it, then the size of the spring changes. When the size of the spring changes, then energy will be stored in the spring as elastic potential energy. Right? Now, we have even studied about the mathematical expression of potential energy. That is, potential energy is equal to mgh. This is the expression for potential energy. So the potential energy of a body depends upon the weight of the body and the height at which the body is located from the center of the earth. Now I have some examples for you here. See, which are the examples of potential energy? First one is wind-up spring of an alarm clock. So earlier we used to have alarm clock to get up early in the morning. For that we used to wind up the spring of the clock. Of course, nowadays we are using our mobile phones only as alarms. So when we used to wind up the spring of an alarm clock, what we used to do? We used to apply our muscular energy in winding the spring. The muscular energy will be stored in the spring as potential energy. Okay. Then compressed spring of a toy pistol. Even if you take a toy pistol, the spring when it is in compressed stage, there also the muscular energy will be stored in it as potential energy. Stretched rubber sling of a catapult. When you stretch the sling of the catapult, then what happens? Your muscular energy will be stored in the sling as energy, that is called potential energy. Stretched string of a bow. Even in a bow also, when you stretch the string, the energy will be stored in the string as potential energy. Even you take water stored in a dam or a reservoir, it will have potential energy. So these are some examples of potential energy. Now coming to units of potential energy. Potential energy is again energy only. So what units you can use? The standard unit of potential energy will be equal to joules only. This you have to. Okay. This will be the standard unit for potential energy. Now let us consider some numerical examples. See, a girl of mass 40 kg climbs up stairs by spending 800 joules of energy. How high does a girl climb up? We are provided with the value of g as 10 meter per second square. Now, already in my previous classes I have told you, whenever you are solving problem, the first thing you have to write is the data given along with the correct units. So what is the data given for us? Mass of the girl is 40 kg. How much is the energy she is spending? That is potential energy is equal to 800 joules. Now, we have to calculate the height at which the girl will be. We are provided with the value of g also as 10 meter per square. Now, potential energy will be equal to mgh. Right? 800 joules will be equal to, substitute 40 into 10 into h. H will be equal to 800 divided by 400, that is equal to 2. So what will be height? Therefore, h is equal to 2 the height of the curve. Okay, note down the solution. Now let us take few more problems on potential energy. I hope you have copied the solution. Okay, next problem. A stone of weight 2 kg is lying on the roof of the building. Meter high. Calculate the amount of stored energy. Calculate the amount of stored energy in the stone. So we have to take 1 kg is equal to 10 Newton. Now here we are provided with gravitational units of weight or force. Now gravitational units is a kilogram force. Gravitational units means what? It is under the body is under the influence of the gravitational force of the earth. So we can note the weight in gravitational units also. Okay. So here he has given a stone of weight 2 kg is lying on the roof of a building 60-meter high. Calculate the amount of stored energy in the stone. Now solution you see, weight is equal to mg is equal to, weight is nothing but mg, right? Weight is equal to mg is equal to 2 kgf. Now weight is nothing but force only, because weight is nothing but the force exerted by the earth on all the objects. Going back to the definition of weight, which you have learned in your lower classes. So weight is nothing but the force exerted by the earth on all its objects. Now here weight is given as 2 kgf, and he has given some hint also. Take 1 kgf as 10 newtons. So if you take 1 kgf as 10 newtons, 2 kgf will be equal to 20 newtons. So this will be equal to 20, right? Next, height how much here given? 60 meters. What you have to calculate? Potential energy. Potential energy is equal to mgh is equal to mg is nothing but w. So w value we know, that is 20 newton multiplied by height is how much? 60 meters. So how much you will get? Potential energy is equal to 20 multiplied by 60 is 1200 Newton meter. Newton meter is the units for work done. Newton meter is nothing but joule only. So this will be the potential energy stored in the ball. Okay. Copy the solution. Okay, children. I will give one problem as homework. You please try to solve that. So two problems I have solved in this class. I will give one problem as homework. Third problem, take it as homework. A ball of mass 60 kg. Sorry, 50 kg. Climbs stairs by spending 1200 joules of energy. How high does the boy climb? Take G is equal to 10 meter per second square. So you have to use potential energy expression only and calculate the height of the ball. Okay. So this will be the homework. Try this out. We shall see in the next video, children. Till then, take care of yourself. Thank you.